incredible news today about shungite and Buckminster fullerenes, which are buckyballs. They look like soccer balls. They have 60 carbons in a basketball-looking shape. Now, I started looking into this because people are asking me, what about this shungite? Everybody's talking about it to be some kind of help against, I guess, the 5G. And there is nothing you can do against the 5G. I'm going to tell you that right at this moment. These things may help you. Yes, they might. I'm not saying they can't, because what I looked into and what I saw, and I have full right here. I mean, shungite here. And it is literally 100% carbon. Now there's tiny, tiny, tiny little trace amount of these Buckminster fullerenes in there, which are these buckyballs. First of all, let me just show you what this is. Now, if you can see this, all right. Now, if you could look real close, you could actually see the fingernail where it is. It comes across the top there. I don't know if that'll be apparent or not, but anyway, this is a fingertip, and it breaks off here. I have another one here. Hold on, I get you one. This is a standard type. You know, it depends on how they get petrified. So they don't have to necessarily be in some place like Russia, because that's where they say the shungite comes from. It comes from anywhere. It depends on how it was interred in the earth and the conditions that it resided in. If it was pointed down, how deep it was, what the pressure was, what the solvomorphism was, what the geothermal activity was. A lot of things going on there. Acid, salts, what's going on? But it's almost 100% carbon, and that's what happens to fossilized creatures. They turn into carbon because all the organic stuff goes away, and the only thing that's left is literally the cell membranes, which are the bags that hold the contents of your cellular gooey stuff that's inside these cells. And every cell has a lining around to keep them from everywhere else. It's called a cell membrane. And in trees and other things, they have cell walls. So in addition to the membranes, they have walls, and that gives them turgidity and so forth. They can stand up and twist, and these cells fill up. And that's why plants are much different than creatures when they petrify. That's a whole other issue. But anyway, I'm going into this shungite because once I start looking into this, I realized, carbon is so incredible in the body. I've been talking about it for a long time, carboxylation. I didn't realize how incredible this stuff is. You know, I mean, I understand it, but I did not understand the ramifications and the nuances here. So let's look into it, because they did some studies on rats, and they found out if they gave them activated charcoal, and I'm going to explain that to what activated charcoal is, but if they gave that to them, some of them lived twice as long as normal. And it all works through your gut, which I've been talking about for a long time. And then carboxylation moves these things through your body. So let's look into that part. But the reason that the shungite might have some beneficial effect in addition to carbon is these Buckminster fullerenes. Now, I don't know if they do anything special. I don't have any special information about that. They are a unique structure. They may house in their internal cavity, like a basketball. It may let some things in there that do something special. That's total speculation. No clue. There's a special little ball of things, and they may just say, "Oh, look at that," and they think it's special, so they make a big deal out of it. Because, let me go through the study that they did on these rats, because it's fascinating. Okay, my friends, I have been asked to look into shungite, which I have, and I have shungite here, and it is nothing special other than it is carbon, and I'm not exactly sure how it formed exactly the way it formed, but it has these patterns in it, these spherical looking patterns, but it's 99% carbon. And they say there is some buckyballs in it, these buckyballs, these little carbon balls. They look like soccer balls, and there's 60 carbons in them, and they say they may extend life. So How could that be? I said, well, let's look into this, And this is the structure of them. They look like these balls. They're carbon balls. So I'm looking through all this, what they say about it. It's all very interesting. And what they end up saying is these are carbon balls. And the real thing that is in shungite is 99% carbon and 0.00001% buckyball. So really, it's carbon. It's carbon. Now, people are wearing them from amulets and all that stuff. I have no idea whether that'll help or not. But this is what drew my attention, was that they did a survey of these rats and how long they would live given different concoctions. Now, what they did was they gave, let me see if I can find it here. They gave, hold on, here it is. Researchers gave the rats buckyballs, and probably a lot of them compared to what you would get in a shungite, in a solution of olive oil injected into their stomachs. Now, they say injected. I think they must have drank it or squirted it in through their mouth, and it didn't go with a needle. Now, one control group, so they had control groups, and they had two of them. One control group received water only, and another plain olive oil only. Now, and the other one had olive oil and carbon. All right, that's very important, oil and carbon. Now, after 36 months, all the water-treated rats were dead, while 67% of the oil-treated rats and a remarkable 100% of buckyball rats were still alive. And then it goes on to say how, well, you can see it. After 36 months, 67% of the oil-treated rats, they had just the oil. And then the buckyball, which was the carbon buckyballs, and the oil on top of that, 33% more of them survived. So let's discuss why I think that might happen. I think it was the carbon. I think it's the carbon that's doing the job there. Not necessarily in a buckyball form. That's fine in buckyballs. Maybe it's better. I don't know. But I can tell you one thing. After looking into some studies, and I've suspected this for a long time. I know you've heard me talk about carboxylation, the metal complexes in your body get moved around by carboxylation. The carbon doesn't get absorbed in your body. Carbon just carries things around in your body, and it builds cell walls and things like that, cell membranes. Very, very necessary item in your body, and you blow it out with carbon dioxide. It attaches to carbonic acids, and they blow out through your lungs, and they go out through all kinds of ways of removing these things through your feces and all that kind of stuff. Very, very excellent thing. Now, and let's go into what it says about activated charcoal, because this is the same thing. Activated charcoal is nothing more than carbon with nothing attached to it, and these carbons are activated. Means that all the organic stuff that normally would attach to it, love to be attached to carbon, we burnt them off. So get out of here, leave. We're going to just get the carbon, and then we're going to put it in a person and say, all right, all you guys that want to attach to the carbon, come on. They start attaching, and then you either blow them out of your lungs, and they actually say that you could take too much carbon, activated carbon, and it would take too much of your good stuff out of you. Now, I don't know if that's true or not. It might be. But let's look at what it says about activated charcoal. Is a fine, odorless black powder often used in emergency rooms to treat overdoses. You take too much of something, they can put this in your stomach, they'll suck it all up, and you just get rid of it through your feces. Its toxin-absorbing properties have a wide range of medicinal and cosmetic uses, though none are scientifically proven. They haven't looked into this. This is a problem. So how do you do with this thing? Superheating natural sources of carbon, such as wood, produces activated charcoal. They're cell membranes. The black powder stops toxins from being absorbed in the stomach by binding to them. They leave them with all these open associated spots in the atom that says, I want to attach to somebody. All right? The body is unable to absorb charcoal. So it goes in and it goes out of you. It's not a big deal unless it takes too much out of you. And so the toxins that bind to the charcoal leave the body in the feces. I mean, how elegant is that? Now, they say the article will discuss some of the ways people use activated charcoal, its potential benefits, and if there are any risks. So, and then it goes, this is a very, very good article, and this is www.medicalnewstoday.com. And so it talks about what is activated charcoal. And it goes on and on and on. Now, listen to this, though. This is, vindication as far as I'm concerned. This is a few of the uses of activated charcoal with some evidence, including the following. Kidney health. Activated charcoal may be able to assist kidney function by filtering out undigested toxins and drugs out of your kidneys that they're not getting digested. Why aren't they getting digested? Why aren't they getting digested? Answer that question. You know. No enzymes. Why don't you have the enzymes? You know the answer to that. You don't have the bacteria that made the enzymes to go down and digest the stuff. So you got to put something in there that can get rid of it. I think this is good. I would try this stuff. Well, for me, I would. I wouldn't say I recommend it to anybody else. But this seems like it's as I went on, I just couldn't believe it. Activated charcoal seems to be especially effective removing toxins derived from urea and main byproduct of protein digestion. Urea is uric acids, urea crystals. I believe those are floating around in the blood causing possibly some issues with rheumatoid arthritis, because those things float around through your body. I think there's some kind of crystals are collecting here and there and inflaming the synovial sheaths that let the tendons slide back and forth on your knuckles and all these places. So more research is needed. Yes, some animal studies show that activated charcoal may help improve kidney function, reduce gastrointestinal inflammation of those chronic kidney disease. It reduces chronic kidney disease. Why you have a chronic kidney disease? You know the answer. You know the answer. Why? You don't have the enzymes to digest the things or you don't have the transition metals to bring the things around, and it all comes back to the bacteria in your body. If you don't have the bacteria in your body, you can't process the products that come into your body. That's why I say castor oil can at least do derivatization of some things, and I think, because it has the hydroxyl group, I think. I don't know. I don't know exact chemistry here, but I'm going to tell you one thing. Carbon, I think, is good. I think it's very good. I like carbon. And you go on through this, it's amazing. Intestinal gas, they're using it to remove intestinal gas. It absorbs all the things that do that. Water filtration. You could take this and use it to clean water absolutely flawlessly. Found out used carbon removed as much as 100% of the fluoride, 32 unfiltered water samples, after 6 months. I mean, this stuff is serious. It's just amazing how many particles will collect on those 4 sites and how many molecules and atoms are in a teaspoon. It covers football fields, I think, at least one, maybe more. Gastrointestinal absorbent, they're using it in overdoses and poisonings. For diarrhea, they're using it. Treatment for diarrhea, look at that. I mean, I didn't realize any of this. They're teeth whitening, and I can understand it. It goes and it binds to things that are, and then they say, well, maybe it does, maybe it doesn't. And nobody tests it. Antiviral, antibacterial, antifungal, detoxifying. I'm not seeing a whole lot of bad things. Activated charcoal toxin absorbing properties may be important here, but there is no significant research. In 2017 review, researchers concluded there was not enough laboratory clinical data. Oh my God, it just never ends. Skincare. Researchers have reported activated charcoal can draw microparticles, I'm telling you, this is just amazing, such as dirt, dust, chemicals, toxins, bacteria, to make removing them easier. Because it attaches to them, and then you wash that stuff away, because that can't You can't absorb that. You can't. It doesn't attach into your body anymore. Deodorant. They use it for deodorant. They put it in your shoes and everything else. Skin infection. They put it in all around the world. They use it for skin infections. Traditional medical practice use activated charcoal powder from coconut shells to treat soft tissue conditions, skin infections. Right. Activated charcoal may have an antibacterial effect, absorbing harmful microbes from wounds. They have several commercially available ones. Now, medical uses of activated charcoal. Emergency room doctors use it for treating overdoses and poisons. Listen to this. Activated charcoal can often help clear toxins and drugs included NSAIDs, sedatives, calcium channel blockers, dapsone, carbamazepine, malaria medications, methoxidant, mild stimulants. Activated charcoal cannot bind to all types of toxins or drugs, especially ones that are corrosive. Ones that the activated charcoal cannot help clear include alcohols, lye, iron, lithium. So you still go get drunk. Petroleum products such as fuel oil, gasoline, paint thinner, and some cleaning products, it will not clear those either. If a person is conscious and alert, and then it goes on about how they do it and how they administer it. But I don't see a whole lot of negatives here. It is the thing that works. It's carboxylation that I've been screaming is what we need. But we really need a database to determine what these different things do to you in different quantities. And what different things are in your body, because you need certain things in your body. I'm going to tell you right now, everybody is basically a human being. Everybody breathes oxygen. Everybody eats. Everybody goes to the bathroom in a couple of different ways. It is just a fact of life. Everybody has stomachs, they have bacteria, they have enzymes, they have transition metals in their body. If they eat healthy, and they put the things in their body that God made and put in the ground, and not the things that put in the boxes with preservatives and additives and methoxynoxetins and things that no human being could pronounce. And you're eating them. What do you think is going to happen? This is chemistry. Your life is just nothing but a bag full of chemicals designed to use the things that are on the earth. You consume them. They are in a biological form to begin with. They aren't stamped out like a pencil or a pen somewhere. They're grown from the original organic molecules that make up biology. So, when you take them into you, your product, your bacteria and your digestive system is designed to dissolve that stuff and turn it into little bitty tiny bits. And I mean tiny, 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 tiny molecules. And who does that? Enzymes. Enzymes are literally just like a prescription from a doctor that has 25 different chemicals in it. All right, so let's just take it, let's pretend we just ate something. It goes in the stomach. After you chew it up, your juices start to work on it right away. And as it goes down your throat, it goes into your stomach, it gets eaten up by acids. When I say eaten up by acids, it gets broken down as much as it can in the stomach. Then it leaves the stomach and it gets out of the acid condition and it hits it with a different, a salty condition, let's say, and that neutralizes the acid so that it doesn't burn holes through your intestines. Now, if you don't have that neutralizer, you're in trouble right there. Right there you're in trouble. So what creates a neutralizer? Everything in your body is created with mucus and membranes. And membranes are made out of carbon. I'm telling you. Membranes are made out of carbon. They're made out of carbon. So, I'm telling you, I'm seeing carbon is just so important as I go through this whole thing. So now, but the bacteria has to do its job. You don't have the bacteria. I don't care how much carbon you have. You're still going to be in trouble. Because the bacteria has to make enzymes, and the enzymes do just like they do in a waste treatment plant. They go out and harvest products from what the waste is. And in your stuff, there's nothing more than waste. It's exactly the same stuff that's going into that waste treatment plant. I hope you understand that. You are nothing more than a chemical factory. Once you hit that intestine, that is the only thing that's happening there. It says, okay, what do we got down here, guys? Just like a chemical factory. They said, whoa, we got way up on the protobacteriosis today. Well, we're going to have to call up the bacteria here. Let me see. We got some certain botulinum or something. Throw that in there. That'll kill off that other thing. And it does, and it accumulates things. It's an enzyme. Enzymes are catalysts. They go in, break things up, and kill things, and they form extreme reactions instantly, thousands and thousands of times a second. They do things, and they do it until they've done their job, and then they go away because that's their job, is to do everything they can do. And when the chemistry that they came to work with is not any longer there, or they just harvested enough, they just go away. And it's a very elegant system. So, if you don't have the enzymes, you are not going to harvest the things you need. You're not going to harvest the metals that you need to do the transition metals to work with the carbon to move these things around your body. It's called carboxylation. Right? And if you can't have the carbon, you can't move things. And then the carbon can't attach to things. You can't blow them out of your lungs. You can't make membranes. You can't make cell linings. Carbon is very, very important. So, I hope you understand that. Now, I don't know about activated charcoal, but, because nobody recommends it, and they say there's no research on it. That's the problem. See, they have a wide range of medicals, but they don't do the research on it. So, and that's what I always say. Well, is this stuff any good? I don't know. We never looked at it. Well, why don't you look at it? This sounds like there's some serious stuff here. I can see the chemistry looks very good to me. And I know that castor oil is, to me, it is a very, very effective remedy for pain in a localized spot. And it seems to have no problems that I can find at this point. But I don't know. I don't have any chemistry on my body. I don't have this database to look to say, okay, what's in my blood, what's in my bacteria, what's in my enzymes, what's in my transition metals, what's in my feces. No database for that. So there's no norm. So I don't know if I'm okay or if I'm bad. I don't know what I compare to with the rest of the world. It's a very difficult situation to put a doctor in to treat someone and not have that information. That's the problem. The doctors are being put in a position is untenable. They cannot do their job until they have that database. I'm sorry. You go all doctors you want, and they're just going to say, how do you feel? You say, I don't feel good. They say, well, you're pretty sick. Let me give you some of this and see what happens. And basically, that's it. They're going to check you for a couple things that everybody has and seems to have enough of, or right on the borderlines, or they're not the things. They're not the very, very, very fine things. The very fine transition metals that are what they call the trace elements. Or they're just a little thing here and there, don't matter. Well, they matter extremely amount. And if they're not there because of a reason. And the reason normally will be the bacteria. So that's what we have to find out. Then that'll lead us to everything else. And sooner or later, there's going to be a database that'll say, these are the norms, and if you're way out of here or way out of that, you're in trouble. And then we know that means you're running low on this other thing. So you take some of that, case is closed. I think we can absolutely affect health. I'm absolutely certain if they would pay more attention to these bodily processes. Not everything is a genetic defect. Understand? You got to get ahead of it. You can't just take your car out and say, "Oh, every time something happens, the camshaft breaks." No. I didn't put any oil in the car. Well, the camshaft broke. Well, I didn't put any oil in the car. The tires went flat. No. You got to take care of all these things. They all got to be taken care of. People think you just eat anything you want, do anything you want, and everything's good. No problem. And then they wonder why they get sick. It just blows my mind. All right, but again, my mind has been blown seriously for a while now. But I don't know, my friends. I would look into a lot of things and pay attention to your own